Electricity plays a vital role in our daily lives. From switching on a light bulb to charging your mobile phone, electricity is involved in nearly everything we do. But what exactly is electricity? And how does it travel from a power station all the way to your house? To understand this, we need to explore the basics, starting with electric circuits. An electric circuit is a complete path through which electricity flows. For current to flow, the circuit must be closed, meaning there should be no breaks in the path. A circuit typically includes a source of electricity like a battery or cell, connecting wires, and a device that uses electricity, such as a bulb or fan. Let's consider a simple real-life example. Take a torch. It has batteries, a switch, and a bulb. When you press the switch, the circuit completes and allows electricity to flow from the battery to the bulb, lighting it up. As soon as you release the switch, the circuit breaks, and the bulb turns off. This shows how switches control the flow of electricity by opening or closing the circuit. Another common example is a doorbell at your home. When you press the button, the circuit closes, allowing current to flow and ring the bell. Release the button, and the circuit breaks, stopping the sound. This is the basic principle behind all electrical appliances, whether it's a washing machine, refrigerator, or ceiling fan. One important concept is the direction of current. In a simple circuit, current flows from the positive terminal of a battery, through the wire, into the appliance, like a bulb, and back to the negative terminal. If this path is broken at any point, the electricity stops flowing and the appliance won't work. Wires that carry current are typically made of conductors, materials that allow electricity to flow easily. Copper and aluminium are good conductors and are used in most household wiring. On the other hand, materials like rubber and plastic are insulators. They don't allow current to pass through and are used to cover wires, ensuring safety. Have you ever wondered why birds sitting on electric wires don't get electrocuted? That's because electricity flows through a complete circuit. If the bird only touches one wire and doesn't form a path for the current to the ground, the circuit isn't complete, so electricity doesn't flow through its body. Now, consider a fuse, a safety device used in many appliances. If the current becomes too strong, the fuse melts and breaks the circuit, preventing possible fires. This is why we say fuses protect our home from electrical accidents. Another interesting device is the electric cell, like the ones used in remote controls or wall clocks. These small cells convert chemical energy into electrical energy and provide a steady flow of current. When the chemicals inside are used up, the cell can no longer produce electricity. We also use series and parallel circuits in our daily life. In series circuits, components are connected end to end. So if one bulb fuses, the entire circuit stops working. In contrast, in a parallel circuit, each component is connected separately to the power source. That's why in homes, even if one light goes off, others continue to work. More practically, think about a school science project. You can connect a bulb, a battery, and a switch using copper wires on a cardboard platform. This model will help you visualize the working of a basic electric circuit. Light bulb emoji, if you're finding this explanation helpful, and it's making your science concepts clearer, then don't forget to like this video and subscribe to the Knowledge Nest. We simplify your science syllabus and bring you clear examples from everyday life. Support us to keep the learning going. Understanding electricity and circuits not only helps in scoring well in exams, but it also builds your foundation for future studies in science and technology. These basic concepts are used in advanced systems like robotics, smart homes, and even space exploration. So the next time you turn on a light, Remember the invisible yet powerful current flowing through the wires, completing a journey that started with just a simple switch.